This video is for the Stewart calculus worksheet, question number 2L, where it asks for concave up, concave down, and points of inflection. And we're also going to show other parts of this graph. So the equation is, the function is y equals x squared over square root x plus 1. So we'll do this over here. So we'll do y equals x squared over square root of x plus 1. Okay, make sure we have some room to work with here. So we want to find the zeros for this, because those are useful points to know. So zeros are at x equals 0. Okay. The domain of this function is very important because this has a domain restriction. So x must be greater than or equal to -1, but -1 is going to give us a vertical asymptote. So we're just going to say that x is greater than or greater than -1. So this is an important domain restriction here that we have to observe. So it's likely going to have an asymptote of -1 and something, some point like that. It's going to come along there and go through 0. So there is our graph. There is our domain. We have our 0. Our y-intercept in this case, okay, if I let my y-intercept is going to be a good point to have, is going to be when x is 0, y is 0. Okay, so that 0 happens to be the y-intercept. Okay, so we want to find our min and max point. So we need a derivative. So the derivative of this function is going to end up being differentiating this using the quotient rule, 2x root x plus 1 minus x squared times 1 over 2 square root x plus 1. And that's going to be all over the denominator, root x plus 1 squared, so it's just going to end up being x plus 1. Okay, so we want to simplify this expression and find the zeros for this. So I'm just going to multiply top and bottom of this by, so I'll just get rid of that root in the denominator. I'm going to multiply by root x plus 1 to root x plus 1. This simplifies then down to, because we have the 2 there, it's going to end up with 4x x plus 1 minus x squared, and then the denominator we're going to end up with 2, and then I'm going to rewrite this as x plus 1 to the power 3 over 2, so 1 plus 1/2. So this is my I've got some like terms here. I should simplify that. So I end up with 4x squared minus x squared is 3x squared plus 4. Okay, that looks right. Okay, so 3x squared plus 4, 4x, sorry. So I should maybe factor that. So it's going to be x times 4x plus, 3x plus 4. Okay, so just making sure I've got my like terms here. 4x squared minus x squared is 3x squared, 4x, and then I factor out the x. Okay, so that looks good. So I'm going to write this over 2x plus 1 to the power 3 over 2. Now I want to make this equal to 0 to find my derivative, so I'm going to make this equal to 0 and solve that numerator equal to 0. So when it's equal to 0, it's at x equals 0 and -4 over 3. Okay, so I have x equals 0 and x is equal to -4 over 3. Now, just when I check my domain though, -4 over 3 is outside my domain, so I know I can ignore that point. And I'm going to start making my slope chart here. So I've got my x is 0, I've got x is -1, that's undefined, and x is 0, it looks like I have a slope of 0, and I'll just test my slopes. So check my slopes. Y prime at -0.5. When I put -0.5 into here, I get -0.5 positive. This is going to be negative 0.5 times 3, so positive, negative, positive, positive. Just making sure, so that's going to be a negative slope through here. Okay, so that's what the slope through that region is going to be, negative in here. Okay, so it's going to be pointing down like this. It's going to come across 0, and then if I test a positive number in here, y prime at 1, positive 1, positive, positive, everything's positive, so we end up with a positive slope. So we know that it's going to go up like that. So we know it's going to go down along the asymptote and come back through here. It looks like we have a minimum point there. And the concavity of this looks like to be positive. So we need to see if there's a change of concavity somewhere. So I'm going to do a second derivative. So y double prime. Okay, so when I do the y double prime, it's going to look a little bit messier here. I think maybe I'll start with y prime is equal to 3x squared plus 4x over 2. Okay, and I'm going to differentiate that expression. So I end up with 6x plus 4 times the denominator. So that's going to be 2 times x plus 1 to the 3 over 2 minus. This is going to be 3x squared plus 4x, and then the derivative of that denominator is going to be 3 over 2 times 2 is just going to give us 3, x plus 1, and I'm going to subtract 1 from the denominator, so I get 1/2, and then that's all over 2 squared. Okay, so I'm going to get 4, and then squaring that, I'm going to get x plus 1 cubed. Okay, so then I should simplify this expression. Looks like maybe if I multiply this by root x plus 1, I can get rid of that power 1/2, x plus 1. In fact, maybe I'm going to divide, because I don't want to introduce more terms than I want. So I'm going to divide by the top and bottom by root x plus 1. So that's going to give me y double prime is equal to 6x plus 4 times 2. I divide by root, I'm going to be left with x plus 1 minus, that's going to get rid of that square root, so I'm going to end up with 3x squared plus 4x, and then in the denominator is going to be 4, and I'm going to take away power 1/2 from here, so x plus 1 to the 5 over 2. So this is 3, this is 2.5, because I'm dividing by a square root, so I'm going to take away a 1/2 power. Okay, now I have a polynomial in the numerator. I'm going to expand this out. So 6x squared plus 6x, 4x, or 10x plus 4 minus 9x squared minus 12x. And that's going to be all over 4 times x plus 1 to the 5 over 2. Combining like terms, 12x squared minus x squared is 3x squared. 20x minus 12x is going to be plus 8x plus 8, and that's all over my denominator. Now I can solve for my inflection point. So I'm going to solve that quadratic equal to 0. When I plug this into the quadratic formula, it doesn't look like it's factorable, so I'm going to plug it into the quadratic formula, -8 plus minus 64 minus 4 times a times c. And I can see that I'm going to end up with a negative number in there. Okay, so there's no real roots here, so this is over 2 times 3. So -8 plus minus 64, that looks like it's going to be 96. Square root 64 minus 96 is -32. Okay, so then that negative indicates that there is no solution. So that means then that the second derivative is never equal to 0. So I can calculate the value of the second derivative. Let's just do it at 0. The second derivative is going to be equal to positive when I plug 0 in. So if I were to do my concavity chart, so this is my slope chart. My concavity chart means that it's positive or concave up for that whole region. So when I sketch this graph, okay, I have a 0 at 0. I've got a vertical asymptote at -1. I think that's the only points I have, and I know it's sloping down. Hits that point, and it's going to go back up. It's going to look like that. Okay, concave up the whole time, negative slope to here, positive slope from here.